right, here we go. Find your 2.6 notes. We're going to spend 3 days on this lesson. So today's Friday, we have Monday, Tuesday. It's going to be due on Wednesday, but you have an additional worksheet that will go with it, and I'll pass that out today. All right, example 1 says find the domain of f of x equals 2x plus 1 over x squared minus 4. All right. Lydia, can you remember what is domain?
The numbers that would be for x.
Good job. Okay, they're the numbers that you can plug in for x. So when you have a fraction, Adam, what do we have to be concerned with when we're talking about domain of a fraction?
The denominator cannot be equal to 0.
Awesome. Okay, the denominator cannot be equal to 0. So, in fact, we're just going to set the denominator equal to 0. So x equals plus or minus 2. So the domain, you can write this one of two ways. You can write it in set notation, the set of all real numbers x, such that x is not equal to plus or minus 2, which in this case I think would be the easier, most efficient manner. Or if you love the challenge of interval notation, you may write it this way. I will accept it in either format. It's describing the same set of numbers. All right, now let's talk asymptotes. The first asymptote we're going to look at are the vertical asymptotes. We cannot formally define it until we get to calculus next year. However, we can do our best to try to describe it as clearly as we can with the math that we know. It says the line x equals a is a vertical asymptote of the graph of f if f of x is approaching positive or negative infinity as x approaches some number a, either from the left or from the right. Let me draw a picture because I don't think that that's real clear here. So if x is a, we're saying this is a vertical asymptote if that piece of graph is either going up to infinity or going down to negative infinity. That's the best we can do through PreCalculus. The line y equals b is a horizontal asymptote of the graph of f if f of x approaches a number b as x is going to positive infinity or negative infinity. So oftentimes we'll have, say we have a horizontal asymptote. Do you see as x is going to the right, it's leveling off to whatever this y value is. That's what the horizontal asymptote means. To find a vertical asymptote, you're going to factor the numerator, factor the denominator, and cancel any common factors. You need to remember this. You can't just say, and I think we were a little careless last year in Algebra 2, that's why I brought, remember removable discontinuities, where there was a hole in the graph? You have to, and we're going to review it. We don't get to it today, we'll get to it Monday. But you have to cancel first, because if a factor cancels in the denominator, it's not a vertical asymptote, it's actually a hole in the graph. So be careful when you say, oh, a vertical asymptote is where the denominator equals 0. That's not necessarily true. If there's a common factor, it'll end up being a hole in the graph instead of a vertical asymptote. To find horizontal asymptotes, you find your numerator and denominator, the degree. If the degree of the numerator is smaller than the degree of the denominator, the horizontal asymptote is y equals 0. So for example, if I give you y equals x squared over 5x to the 4th plus 1, the degree of the numerator is 2. The degree of the denominator is 4, so it has a horizontal asymptote of y equals 0. If the degrees are equal, so let's say I have 3x squared plus 1 over 5x squared minus x, the horizontal asymptote will be equal to the coefficients of those degreed terms. So this would be y equals 3/5. It's the coefficient of the x squareds. If the degree of the numerator is greater than the degree of the denominator, then there's no horizontal asymptote. So what if I have y equals x squared over 1 minus x? There's no horizontal asymptote, but if you remember from last year in Algebra 2, what kind of asymptote do we have besides a vertical? A slant asymptote, and we're going to hit slant asymptotes this year. I think last year I introduced it. It wasn't necessarily a requirement, but we're going to look at those. All right, so we've got domain and asymptotes. So let's look at example 2. I'm going to give you a head start on me. I want you to find any horizontal or vertical asymptotes for A, B, and C.